Download this code from codegive.com, link in the description below. Building dams ahead of winter, understanding busy beavers and simulating dam construction in Yellowstone. This tutorial dives into the fascinating world of beavers, particularly their crucial role in building dams before the harsh Yellowstone winter. We'll explore their behavior, the ecological significance of their dams, and then develop a simple Python simulation to visualize dam construction. This will echo themes often seen in BBC Earth documentaries about Yellowstone's wildlife. Part 1, The Busy Beaver, Engineers of the Yellowstone Ecosystem. Beavers, Castor canadensis, are semi-aquatic rodents native to North America and a keystone species in many ecosystems, including Yellowstone National Park. They are renowned for their engineering skills, specifically their ability to construct dams that dramatically alter landscapes and create wetlands. 1.1. Why build dams? The beaver's perspective *****. Safety from predators ****. Beavers are vulnerable to predators like coyotes, wolves, and bears, especially on land. Dams create ponds and wetlands, allowing them to build lodges in the center of the water, accessible only through underwater entrances. This significantly reduces their risk of predation. Access to food Beavers primarily eat the bark and cambium, the layer under the bark, of trees, particularly aspen, willow, and cottonwood. The ponds created by dams allow them to easily float logs back to their lodges for consumption. They can also stockpile food underwater near their lodges for the winter months. Water level management consistent water levels, maintained by dams, prevent their lodge entrances from freezing shut in the winter. This is crucial for survival in a harsh environment like Yellowstone. Transport ponds facilitate the transportation of materials, trees, mud, stones, for dam and lodge construction. 1.2. The role of dams in the Yellowstone ecosystem ****. Beaver dams are not merely beaver homes, they are vital ecosystem engineers, profoundly shaping the landscape and benefiting a wide range of species. Wetland creation The most obvious effect of a dam is the creation of a pond or wetland. Wetlands are among the most productive ecosystems on Earth, supporting a high diversity of plant and animal life. Water storage Dams act as natural reservoirs, storing water during periods of high runoff, like spring snow melt, and releasing it slowly throughout the year. This helps regulate stream flow and prevents both flooding and drought. Sediment trapping Dams trap sediment and nutrients, which can improve water quality downstream and create fertile soils in the pond itself. Groundwater recharge The ponds created by dams increase groundwater recharge, raising the water table and benefiting riparian vegetation. Habitat creation Beaver ponds create habitat for a variety of species, including waterfowl, amphibians, fish, insects, and mammals. They increase the complexity and diversity of the landscape. Many bird species, like the American dipper, a bird often filmed by BBC Earth in Yellowstone, rely on the open water created by beaver dams in winter to access invertebrates. Altered stream morphology Beaver dams can change the shape of streams, making them wider and shallower. This can create more suitable habitat for fish and other aquatic organisms. Nutrient cycling Beaver activities influence nutrient cycling in ecosystems. For example, the decomposition of flooded vegetation releases nutrients into the water, supporting the food web. 1.3. Beaver Dam Construction, a masterclass in natural engineering ****. Beavers are incredibly efficient dam builders, following a set of principles. Location, Location * beavers carefully select dam sites, typically in narrow sections of streams or rivers with stable banks. Building materials * they primarily use trees, especially aspen and willow, branches, mud, stones, and vegetation. Anchoring * they start by anchoring the dam to the stream banks with larger logs and rocks. Layering * they then build up the dam in layers, alternating between logs, branches, and mud. The mud acts as a sealant, making the dam watertight. Maintenance * beavers are constantly maintaining and repairing their dams, especially after storms or floods. Cooperative effort * beaver families work together to build and maintain dams, demonstrating impressive social cooperation. Part 2, Simulating Dam Construction in Python. Now, let's create a simple Python simulation to visualize the process of beaver dam construction. This will be a simplified model, but it will capture the basic principles. 2.1. Setting up the environment. First, make sure you have Python installed. We'll use the Matplotlib library for visualization. 2.2. Code implementation. Here's the Python code for our dam construction simulation. 2.3. Code explanation. 1 Beaver dam class ********* init___ initializes the dam with a given width, height, and initial water level. The dam is represented as a 2D list, a list of lists, where 0 represents an empty space and 1 represents a part of the dam. ****material, x, y, adds dam material, represented by 1, to a specific coordinate, x, y, within the dam structure, if the location is empty. ****build_dam, iterations, simulates the dam construction process. ****it iterates a specified number of times, iterations. In each iteration, it randomly chooses a starting location at the base of the dam. It then attempts to add material to adjacent cells, simulating the beaver's movement and material placement. It favors adding material at the bottom of the dam. After the construction iterations, it estimates the water level based on how many cells are filled with dam material. A simple calculation estimates a water level that should be roughly proportional to the amount of material added. ****display_dam, visualizes the dam using Matplotlib. ****plt.im show displays the 2D array, self.dam, as an image. Map equals gray_r uses a reversed grayscale color map, so 1, dam material, appears darker than 0, empty. Origin equals upper ensures the origin is at the top left, matching the array structure. Extent sets the x and y axis ranges. ****plt.gca.add_patch draws a blue rectangle to represent the water level, adding a visual element. The title displays the number of materials collected and the water level. 2 Simulation setup ****. We define the dam_width, dam_height, and construction_iterations to control the size of the dam and the duration of the simulation. We create an instance of the beaver dam class and run the build_dam method to construct the dam. Finally, we call display_dam to visualize the results. 2.4. Running the code ****. Save the code as a .py file, example beaver_dam.py, and run it from your terminal. This will display a grayscale image of the simulated beaver dam, with a blue rectangle representing the water level. The title of the image will show how many pieces of material were used and the resulting water level. 2.5. Customization and enhancements ****. More realistic material placement. Instead of random placement, you could implement rules based on the existing structure. For example, beavers might preferentially add material to areas where the dam is weak or where there are gaps. Tree felling simulation. Add a function to simulate beavers felling trees near the river and transporting them to the dam site. Stream flow simulation. Model the flow of water through the dam and how it affects the dam's stability. Seasonal effects. Simulate how the water level changes throughout the year due to snow melt and rainfall. Predation. Add a predator component, where predators occasionally attack beavers on land. The dam provides refuge from predators. Multiple dams. Allow the simulation to create multiple dams along a river. Habitat diversity calculation. Add metrics that calculate the potential habitat diversity created by the dam, example surface area of the pond, length of the shoreline. This relates directly to the ecological importance highlighted in BBC Earth documentaries. GUI. Convert the simulation to a graphical user interface, GUI, for easier interaction. More sophisticated water level calculation. Calculate the water level based on a physics simulation, considering the dam's porosity and the water inflow. Visualization improvements. Use more visually appealing colors, textures, and animation to create a more engaging simulation. Agent-based modeling. Implement the simulation as an agent-based model, ABM, where individual beavers are represented as agents with their own behaviors and interactions. This can simulate colony dynamics and more complex dam building strategies. Example of adding a simple tree felling simulation. In this added example, fell_tree is added to the beaver dam class to simulate felling of trees. Then the build_dam method has been updated to periodically call the fell_tree function. This will increase the material collected randomly. This is a starting point. The felling could be linked to distance, terrain and other factors. Part 3, Connecting to BBC Earth and Yellowstone visualizations. Imagine the dramatic visuals often seen in BBC Earth documentaries about Yellowstone. Time lapses of dam construction. Our simulation provides a simplified version of these time lapses. You could improve the simulation to generate frames that could be stitched together into a basic animation. Aerial shots of beaver ponds in winter. The visualization in our simulation could be modified to look more like an aerial shot, with snow-covered banks and frozen water. Color palettes and texture could be enhanced. Close-ups of beavers working on their dams. Our simulation can't capture the details of beaver behavior, but you could add elements that represent beaver activity, such as visual cues that indicate material transport. Slow-motion shots of water flowing over the dam. A more advanced simulation could model the physics of water flow and render slow-motion visualizations. Showcasing the biodiversity supported by beaver dams. You could add visualizations that represent the different species that benefit from beaver dams. For example, show the number of fish, birds, or amphibians in the beaver pond. You could even link this to habitat metrics calculated in the simulation. By improving the simulation, you can create compelling visualizations that echo the beauty and ecological significance of beaver dams in Yellowstone, as often depicted in BBC Earth documentaries. This exercise helps understand not only the beavers' engineering prowess but also the broader ecological impact of their activities, especially in preparing for the harsh Yellowstone winter. Remember, this is just a starting point. You can expand and refine the simulation to make it more realistic and visually appealing. Good luck.